So, if you're all settled in, our next speaker, Mr. Mukharjee, will give us an astonishingly wonderful talk in Hindi.
So thank you everyone for coming. As
भाई लोग ताली बजाओ.
As Gautam mentioned, my name is Aditya, and this talk is titled Goro, Translating Go to Other Human Languages and Back Again. For those of you who don't know me, I'm a systems engineer at Stripe, and that means that my job is to write open source software for monitoring and reliability. And I've been writing Go full-time for the past 5 years now. And a lot is, actually 6 years now. So a lot has changed in that time. This here is from the source code of the Go 1.0 compiler back in 2012. So if you don't write C, there's a lot of unfamiliar stuff here. You might be able to get a sense of what's happening, but not really completely. And it would be much harder to write it yourself than to read it and understand what's going on. And this was a huge barrier to contributing to the Go project, and everyone knew it. So think about it. We're here to contribute to the Go project. We already all know and use Go. So why should we need to learn a whole different language, C, just to contribute to Go? And to address this, we rewrote the entire Go compiler from C to Go, and that was released in 2015. We did this largely using a C to Go translator that translated the code automatically, and then the remainder was done by hand, little fine-tuning fixes here and there. This is a great talk from the very first GopherCon about what this translation process was like and the process of building a C to Go translator for the compiler. But that only removed one language barrier, and there's still one more to contributing to Go. Go development happens almost entirely in English. That's true both of the official Go project, but also of popular projects that use Go, like Kubernetes or Docker or Grafana. And a person's ability to contribute to those projects is greatly limited if they don't have at least a working grasp of English. Even reading the code, understanding what things like char and scale mean, that's something that we might take for granted if we do speak English, but for some people, even reading a Latin script is an extra challenge. So since computers are here to make our lives easier, let's see what computers can do to fix it. And in the Go community, we already have a lot of people who don't speak English as their first language, or speak English very fluently, or even speak English at all. There are many people here who probably speak English as a second language, but for instance, the Chinese Go community has actually translated the official Go documentation into Chinese for people who only speak Chinese, and it's complete with the iconic Go Gopher mascot. And there are other projects and resources you can find on GitHub and elsewhere in which everything from the README to the comments and the issue tracking all happen in Chinese. GopherCon Brazil is a bilingual conference, and it has talks in both English and in Portuguese. So it's great that Chinese and Brazilian Gophers have developed thriving communities for themselves, but fragmenting resources is bad for open source development. Fragmentation means duplicated work, and it means incompatible interfaces. So how do we bridge these communities together? The idea of eliminating natural language barriers to programming isn't new at all, and in fact, it's very old. Grace Hopper was one of the first computer scientists, and she wrote the very first compiler for a programming language. And the language that she invented was called COBOL. The goal was to have English-like natural language syntax so that business executives could write code. And she received incredible pushback about this. Engineers were furious. They thought, well, if non-engineers could write code, this could put them, the engineers, out of a job. But Hopper's vision took this even further. Why restrict this to English-like syntax? What if developers who spoke other languages wanted to write programs as well? She wanted COBOL to be, and I quote, a language you can use to talk to programmers around the world. And the response to that was even more vitriolic. They said, well, how can we teach American computers to run German programs? And to be clear here, this is not a question of how it could be done technically, but a political one. Even though this was a decade and a half after World War II, the fear of a threat from Germany or Russia was still very strong in people's minds. But even if Hopper's idea was put on the back burner due to xenophobia and politics in the 1950s, we can look at what it means today and learn from that approach. This is Hopper speaking about COBOL many years later. She said, I would have thought it would be useful to NATO because they had the common verbs for the things they were going to do. And the nouns, they'd just have to have a dictionary for things they were referring to for inventory control. They'd have common nouns throughout NATO, and they could make a dictionary of common verbs and translate the program. You could write one in English, and you could translate it, and it could go to the other language. No problem, you'd have communication. It would be a limited vocabulary. Now, interestingly, Hopper chose the imperative mood for a language specifically because she believed it would be universal to all languages. Not all languages distinguish between present, past, and future tenses, but languages generally have a way of commanding people to do something. And COBOL was one of the languages which popularized imperative programming styles, so this has actually stuck with us to this day. Notice how even in Go, function names are generally imperative. We say read, write. This is indirectly a result of this tradition. And Go also takes one other inspiration from COBOL. Does anyone know what it is? Yep. It's the time parsing function. Time.parse is actually modeled after COBOL's picture clauses. So let's see what we get when we take those same techniques that we use to translate the Go compiler from C into Go and apply them to Hopper's vision of translating from one language to another. So to answer this question, we can look at Goro. Goro is an extension of the Go compiler and toolchain to support Bengali. And the name Goro, as you may guess if you do speak Hindi, is an idiomatic translation of the word go in English. It literally means do. And a shout out here to Alice Kelly for drawing this gopher-tiger hybrid. In case you can't actually see, the tiger is in the shape of the letter ka right there. Notice how his tail curves around right there. I thought that was brilliant. So thank you, Alice. Now, I chose Bengali for this proof of concept for a few reasons. I mean, first of all, it's the language my family speaks, so it's a little bit easier to start with something you already know. But in addition, it's a pretty common language. After Hindi, it's the most common first language in India, and it's the 7th most widely spoken language in the entire world. So it has a huge, Bengali has a very large reach. It has a wide impact. But in addition, it also uses a non-Latin script. And that's actually pretty important because there is a default assumption when writing code for defaulting to Latin scripts, and so we need to be sure that we can actually handle and deal with scripts that aren't Latin based like English or Spanish. And so nothing that I'm presenting here that I'm about to show is unique to Bengali. So if you're interested in doing this with your own language, I'd highly encourage you to try this out as well. So what have we done? Well, this is a familiar Hello World program that's written in Go. We'll always print Hello World and then exit. And then here's that equivalent program written in Goro. So we've left the identifier names intact, but the keywords are all now in Bengali. And it's true, true is not actually a keyword in Go. People are sometimes surprised to learn that. It's an exported, variable, but it's not a keyword. So the first challenge that we need to do here is we need to get this program to run, because if we try to feed this to the standard Go compiler, it won't know what to do with these keywords. It'll just crash. So Go's source code is all UTF-8. So that means that the compiler has no trouble dealing with non-ASCII characters in Go programs per se. And remember what we said at the beginning, that the Go compiler is now written in Go. So the Go compiler is itself just a Go program. And that means that the Go compiler has no trouble, theoretically, dealing with non-ASCII keyword definitions. There are a few internal checks that are put to ensure that non-Latin and non-alphabetic characters are excluded from keywords. But it turns out that you can just delete those checks and have no problem. So all we have to do is delete those checks and then extend the lexer to handle the Bengali translations of each keyword. And so this is important. There's a reason that I'm giving this talk at a Go conference and not, for example, a Python conference. It's true that I love Go. I've been writing it for 6 years now, but more than that, this is literally not something that you can actually do in Python, at least not so easily. Even in the original Go compiler before 2015, written in C, this would have been much harder. Because remember, this is all being done by the lexer. The parser has no idea that anything's changed. Once you get to the parsing step, it still sees the same identifiers that it would if you were using the English version of Go. So this isn't something you can easily do in most other languages because they use flex-based lexers, and lex and flex don't support multi-byte code points. You actually have to go into the parser as well and change change some of the logic for parsing the code in addition to the lexer. So by the way, some of these translations were straightforward and some were really fun, like fall through. Like, how do you translate the word fall through to, another language as a keyword? So, if you speak a language that's not English, try and think about how you might translate those Go keywords into other languages. It can be kind of fun. So now that we've made those changes, here's what that Hello World program looks like in practice. We start off, we just, yep, and there we go. It runs. We get the Hello World. But remember, our goal here is to defragment the open source community, not to fragment it any further. So we need to make sure that our code is interoperable with code that's written by English-speaking Go developers as well. And we don't want to have to translate every program manually. Fortunately, for the translation step, Go already has a handy utility for formatting source code, GoFormat, or GoFumped if you're one of those weird people who pronounces it that way. Normally we use GoFormat to prevent bike shedding over things like the tabs versus spaces argument. So instead of arguing over the proper way to format source code, everyone just sets up their editor the way they want, as tabs or spaces in whatever width. And if I want to use 4 spaces for indentation and you want to use 2 spaces, then that's okay. GoFormat means we can still work together because we each set up our editors to render tabs with the width we want. And then after we save our code, we run GoFormat, and it will automatically translate our code to the standard style. There's no work needed. And in fact, we don't even need to be aware that we have different indentation preferences because the code that gets committed is committed in the standard form, and our editors are what display it in our preferred forms. But GoFormat can handle a lot more too. Like, it can handle removing unnecessary parentheses, and it's syntax aware, so it's smart enough that it will never change the semantics of your code, which is a simple way of saying something more complex. It's that it's a great way of performing fully isomorphic translations of source code, which is exactly what we need. So we can extend GoFormat and repurpose it for translating English Go code into Bengali or Bengali Go code into English. And that's what Goro format does. So let's take that original Hello World program and translate it back into English-speaking Go. So you start off with this Hello World that's written partially in Bengali, and Goro format will translate back into English. And if you don't believe it, you can verify that it actually still does have the exact same semantics. We can write that to a file, and we can run it. There we go. So we've now just translated a computer program from Bengali back into English. I think that's a little impressive. I don't know if everyone's asleep or something, but I think that was pretty impressive, right? Yeah. So the same way that you didn't know that I was using 4 spaces and I didn't know that you were using 2, having bidirectional translation layers means that you don't need to know that I'm writing my code in English, and I don't need to know that you're writing your code in Bengali or in Hindi or in Marathi or in Telugu. We can localize source code as a commit hook. And as a developer, Goro means that you only ever need to be able to look at source code in your own language. So as far as the code is concerned, our language preferences are now no more of a barrier between you and me working together than our indentation preferences are. And that's the way that it should be. So we've translated the keywords now, but you'll notice that we didn't touch everything. Like, we didn't get the package or the variable names. We just got the keywords so far. And there's a lot of ink that's been spilled on the topic of choosing good variable names. There's the one thing that everyone seems to sort of agree on is that they should be both descriptive and concise. But of course, if we leave the names in English, as most open source projects do, then that's not very descriptive to someone who can't speak English, right? So we need a way to translate these as well. And fortunately, in reality, many variable and function names are already highly structured in code. To use Hopper's framework, we already have the verbs that we use quite frequently when writing code. So we can take advantage of that knowledge and translate those common verbs in the translation step as well. And again, GoFormat already gives us these basic building blocks to make renaming transformations like these. So we can start off and we can translate read foo, write foo, close, etc. into their Bengali equivalents. And by being a little bit more conscious about the conventions we're already using, like using read, write, close as common verbs, we can make our code much more accessible to non-English speakers. So in this case, we might not know what foo is in this case. It's something that we can't translate. But even if you don't know what foo is, if you can read either the right or the left-hand side, you know that boro leko, you can tell that it's reading or writing something. That gives you some important context. So we might not get all of the translations for free, but we can still get many of them, and that's a huge step forward for someone who doesn't read the Latin script or doesn't speak English. Going even beyond that, for many of us, coming to Go meant getting used to a completely different strategy for error handling. So like instead of throwing exceptions, we return errors. And that takes some getting used to, but eventually we learned that there are some amazing advantages to this approach, as Rob Pike's blog post, Errors Are Values, goes into. And that concept, errors are values, it means a lot of things. It means that we can assign the return value of a function as an error and then operate that on that error value as a first-class citizen of the language. It means we can store it on a struct to record it, like the scanner package in the standard library does. It means we can ask that error type what other interface types it satisfies. Go's error handling is probably the most expressive error handling system of any language that I've ever used. And I've spoken about this previously. Like if you're interested in hearing more about how to take advantage of Go's error handling system with interface types, you can check out, I gave a talk right here at GopherCon India 2 years ago on that. But in the context of translating code between languages, treating errors as values lets us do something that's very important as well. We can localize our error messages. Because in Go, the string that's returned by the error method is the only value you can guarantee is always available for every single error that you'll ever encounter. And that's a really powerful but simple contract. It's considered bad form to try and parse this error string, and I would agree very strongly with that recommendation. But because it's considered bad form to try and parse the error string automatically, that makes it all the more important for us to be able to render error messages in a way that's readable and interpretable to the developer who's actually going to be looking at them. Because remember, as developers, we've all struggled with cryptic error messages. This one right here is one of my absolute all-time favorites. It's from Java. It's cannot cast parameter type from type system.string to argument type system.string. Does anyone have any idea what this means, what the error is? This is not a rhetorical question. I actually have no idea. I encountered this a while ago, and I don't write Java anymore, so I've completely forgotten. This is a real error message, though. You can encounter this in Java, and I have no idea what you would do to fix it. And it's easy to poke fun in this case at Java, but it's not like Go is immune to this either. If you ever want to derail your coworkers and stop them from being productive, just ask them what's the most cryptic error message they've ever found in Go code, and trust me, it'll kill the entire afternoon. But the only thing that's worse than cryptic error messages like these is a cryptic error message in a foreign language that you can't even understand. And so error messages are a really great starting point for translation because not only are they finite in number, there are a finite number of places that you initialize error values, but translating them has a huge impact on your collaborators as well. And they're the easiest to solve technically because we can already use existing techniques for localization. Most languages already have libraries that assist with localization. They'll provide variants of specific textual strings depending on the designated locale. And they'll assist with things like pluralizing or capitalization, which are relevant in some languages, but not always the same rules in others. And Go has libraries for internationalization and localization as well. But remember, our goal is to do this all automatically. And we might be able to do, so far we've seen a lot of things that we can do automatically, and translating error messages by hand is fine because you have to write them by hand anyway. But documentation is, that starts to get a little bit trickier. Now, I'm sure I'm not the only one here who's amused themselves by taking Babelfish or Google Translate and seeing how machine-generated translations, they'll stumble over idioms or words that have multiple meanings. But it turns out that Google Translate can actually work quite well for technical documentation. If you ask Russ Cox, he'll tell you not to use C2Go for other projects because it's not designed to work on all arbitrary C code. It's just designed to work on the type of C code that was written for the Go compiler. And similarly, we're not looking at translating all English to another language and back again. We're only looking at translating our open source software, both the code and the documentation. And as it turns out, automatic translation does work particularly well for specialized technical texts and texts that have very narrow context, which is conveniently exactly what we need. So you want to see an example of what this looks like. Here's some documentation from the standard library, the I/O package on pipes. On the left is the original documentation as written in English, and on the right, you'll see just a translation of that into Bengali using Google Translate. And of course, if you don't read Bengali, that doesn't look very impressive. Like, I could tell you, it's a pretty good translation and ask you to take my word for it, but that would be kind of anticlimactic to present in a talk like this. So to demonstrate what this is like, let's see what happens if we try to translate the Bengali text back into English and use that as a proxy for how much information is lost in the process. So if we do that, we get some amusing errors, like in the first paragraph, you have the word code, or phrase code. It's repeated twice. But even then, if you read it, you still do get the general gist of what's going on. And I didn't touch anything else, by the way. Like, all of the punctuation, capitalization, this is all exactly what Google Translate provides. So like, Bengali doesn't even have capital letters, but it's still able to translate that back correctly from the context. Again, it works well for specialized text with technical context. So maybe you're still skeptical, which is fine. So let's try translating the original text into Bengali, translating the Bengali text into Spanish, and then translate that back into English and see what it looks like when you have 3 hops like this. So I won't lie, this isn't great. But you can still kind of get a sense of what's going on here. It is reasonably usable. And it might not be the best documentation that you've ever read, but I can guarantee you it's definitely not the worst. Right? Yeah. And it's a whole heck of a lot better than the alternative, which is no documentation at all. Like, who would rather read something like this, which is, you've got all the right keywords there and sort of in the right places, you just need to kind of fill in the gaps yourself, versus a completely undocumented function entirely, right? I mean, it's a no-brainer. So where do we go from here? There are a lot of different steps that we could take to including non-English speakers more in open source Go development. And making tool chains for translating code and documentation to other languages, like we saw here with Goro, that's just one of them. If anyone's interested in going home and making a variant of Go like Goro does for their own language, I'd highly recommend you go do that. Come talk to me. I'll even help you. You can use Goro as a good starting point. It serves as a nice template for what kind of changes you would need to make in order to make this kind of translation feasible. But so some of these steps we could take involve building new technology and tools to solve the problem, but others are straightforward and low tech, and they involve the way that we operate as a community as well. We're really just scratching the surface here. The key thing is that for any of this to happen, we need to commit ourselves to actually doing it. And we need to commit ourselves because it matters. We need to remember that 95% of the world doesn't speak English as their first language, and 89% of the world doesn't speak English at all. So if this conference were perfectly representative of the entire world in every way, only a small handful of people sitting in this room would even be able to understand this talk, period. And of course, half of those would be listening to me speak in what's for them a foreign language. So between UTF-8, which gives us a nice way to deal with all the characters that have been coded in language worldwide, with an asterisk. And we have Go format, which gives us an easy way to translate and make syntax-aware translations of Go source code. And already having a large community of bilingual speakers, including many of the people who are sitting here in this audience right now. Between all of these things, no other language is as well suited as Go is to being used by the entire world, not just those 5 to 10% who do speak English to different degrees. So that means that we have an opportunity to bridge this language divide with Go in a way that no other programming language has ever been able to do in history. So let's do it. Let's make Go the first programming language that's truly accessible to everyone, no matter what language that you speak. Thank you.
All right. Thanks, Aditya. Before we get on to questions, Vishal Bayani? Yeah, thanks, man. You're saving my day. All right, let's take a few questions. Anyone has a question in Bengali, please? Yes. The mic's coming up. Hang on.
Hello. Yeah, so Bengali and Hindi don't have capital letters. So how do you work around
Exporting?
They don't have capital letters, right?
Yeah.
So how do you go express what is to be exported and what is not to be exported?
I was hoping you'd ask that. So there's actually an open ticket on the Go project list about handling this. There are a couple of different constraints. The main thing is that you can deal with this by including a special character at the beginning, which is basically treated by the compiler as an exported character. There are other proposals to do basically the opposite, because if you preface anything with an underscore, it's treated as a lowercase letter. The key thing with the Go project is that they wanted to make exporting not the default behavior. You have to make an active decision to export an identifier. And so I think what's likely going to happen is that it'll be something along the lines of keywords that a language like Bengali, letters will all be treated as lowercase, and you'll preface it with a separate sentinel character to actively export it. But if this is something that's of interest to you, I would recommend commenting on that, because there are a lot of nuances to how we need to do this in order to get it right, specifically around making isomorphic and like round-trippable translations. If you search for exported identifier in the Go tracker, you'll probably find it.
A quick question from me, though. So I love the way you actually get localized in the code, but do you foresee did you do this for fun and learning, or do you foresee some future in the way programming changes?
Both. So in terms of Goro, like I wrote this as a demonstration that if you talk to most people who haven't seen a talk like this and ask them about what it would be like to translate code from one language to another, everyone will hone in on the technical aspects, and they'll think that the source code is the hardest part to translate, because we're engineers and that's the way we're oriented. But it turns out that's not the hardest part at all. That's actually the easiest part to solve technically, as we can see. The harder part is actually all of the other stuff around it, and orienting the community in a truly multilingual way. And that's something that we are going to have to do, because as you saw, like 90% of the world doesn't speak English at all. That means that we have two options. Either we can have a multilingual, we can have a language that embraces multilingual workflows, or we can basically say that we're going to shut off access to development to 90% of the world. And even if you think that saying like, well, we'll use a single common language for everything, that actually doesn't work so well, because languages diverge over time. Even if you try to standardize around a single language, even a language like English, there's not one English. There are many different dialects and registers. And if we try to standardize around that, it's a moving target. Like, it's no secret that as other languages, like you look at JavaScript, as JavaScript has grown and it's now used not just client-side, but also server-side in different contexts, we have different dialects. We have CoffeeScript, we have TypeScript, we have React, which is almost a new language or new paradigm unto itself. As they grow, we get different forks and variants, and just as programming languages diverge, natural languages will too. So we need to embrace it.
Yep, well said.
Thank you.
All right, thank you so much, Aditya.
Thank you.
All right.